Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thank you for joining us today. I'm your host, Henry Regis, and running the technical side of our program is our very own Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording it for future viewing on our website. And all of our Weather Talk webinars are sponsored by grants from the National Science Foundation and donations from listeners like you. Well, today we're going to cover the fifth region in our climate series and talk about the weather and climate of the Northeastern United States. A good many of you out there live in the Northeast, and this webinar will be of special interest to you. But if you're from other parts of the country, you can learn a lot as well. With us today is climatologist Samantha Borisoff from the Northeast Regional Climate Center located at Cornell University in Ithaca, New York. She is also the New York CoCoRaHS State Coordinator, so many of you may have contacted her already through emails. The Northeast Regional Climate Center focuses on a 12-state region all the way from Maine through West Virginia. Well, severe weather near Samantha's hometown of Wolfsburg, Pennsylvania, sparked her interest in weather at a young age. She received her meteorology degree from Penn State and was a weathercaster way up in Presque Isle, Maine, and also in Binghamton, New York. Outside of weather, Samantha enjoys baking, golfing, traveling, and spending time with her family. Well, Samantha, welcome. Thanks for being with us today. I got two questions for you. First of all, tell me, what is your favorite thing to bake? And secondly, a little bit about the severe weather event that got you interested in climate and weather.
Sure. So what I like to bake, I have to admit, I love pumpkin, and we're just kind of getting into pumpkin season. So pumpkin muffins are one of my favorite things to make. And
that sounds great. We'll be expecting a package sometime in September here.
Sure.
Thanks.
And as far as the severe weather, there was a tornado that went near my hometown when I was younger, and actually I had a pretty healthy fear of thunderstorms as a child. They always scared me, so instead of being scared, I decided to learn about them and become a meteorologist.
Well, great. Well, go ahead. It looks like your presentation is loaded, and we're going to sit back and enjoy your talk today.
Okay, thanks everyone. Thanks for being here. I'm going to talk about the weather and climate of the Northeast U.S. As Henry said, we do cover a 12-state region, and I'm going to start off a little bit talking about what the NRCC is, and then I'll go into some of the more in-depth conditions across the Northeast. So a little bit about the NRCC, or the Northeast Regional Climate Center. It's one of 6 NOAA-funded regional climate centers across the U.S., and you've heard from 4 previous climate centers about their specific regions. The NRCC is located here at Cornell in Ithaca, New York, and we do have a couple of main functions. First of all, we collect, distribute, and help others use climate data, and of course that data does include CoCoRaHS data. And this table down here at the bottom is from one of our databases. And you can see right here this whole list of CoCoRaHS sites. This is actually from a severe rainfall event that just happened recently just near Baltimore, Maryland. So you can see all the CoCoRaHS sites that we have data for, and this is just a small portion of our database. So we definitely use CoCoRaHS, and it's a huge important part of our database. We collect and distribute and help others use that climate data. And as you can see, like I said, there are plenty of CoCoRaHS sites. We monitor and assess climate conditions and impacts. So when things happen, we say, okay, how does this fit into the context of historical context? And we also develop and maintain climate tools and do research. We do cover a 12-state region, and that does span, like Henry said, from West Virginia down to Maine, and it's a very diverse region. So based on the 2010 census, we have the most rural states, which are actually Maine and Vermont, and we have the second most urban state, which is New Jersey. So quite a diverse region. We do have heavily populated areas along the I-95 corridor. So we have cities from Washington, D.C., Baltimore, Maryland, Philadelphia, New York City, and Boston. In fact, New York City and Newark, that urban area is the nation's most populated with 18.3 million residents as of 2010. And I chose this picture. I just saw it online and I just thought it was such an amazing, beautiful photo. But it shows pretty nicely some of our major urban areas, so Baltimore, Washington, Philly, New York City / Newark. These metro areas actually create their own little microclimates, and they're called urban heat islands. And what happens is these areas tend to be a little warmer than their surroundings, and they actually stay warmer at night. And the reason for that is they have a lot more surfaces that that absorb and radiate heat. So things such as roads and buildings, they have a higher density of these things that absorb and radiate heat. So they stay a little warmer. Also, they have a lot more cars, and they have different things like air conditioners and extra things that are pumping out all this heat as well. So that kind of combination makes these areas a little warmer, and they actually don't cool off at night as well either. So this is a diagram showing that a little bit. So you can see temperature at the downtown area as an example, which is higher compared to the suburban areas or the rural farmlands or the parks. The image on the top right is pretty interesting. So this is showing New York City, so Manhattan, Central Park, and this blue rectangle right here is actually Central Park. So that light blue color is denoting temperatures in the upper 70s to low 80s. But if you look around, so the city, Manhattan, and areas around the green area of Central Park, they're running about 10 to 15 degrees warmer than Central Park. So this is kind of a little example of showing how these green spaces tend to be a little cooler, but really that the city areas, the urbanized areas, tend to run warmer than their surrounding areas. And I just want to point out that these darker blue areas are actually at the Hudson River and the East River. So those are water sources. We also have beaches, of course, along the Atlantic Ocean and the Great Lakes. 9 states have Atlantic coastlines, and 2 states have coastlines along the Great Lakes. The ocean, lakes, rivers, they're all very important to our economy. Things like commercial fishing and recreation and tourism are, examples of how they contribute to our economy. And of course, the bodies of water have major influences on our climate as well, so they moderate nearby areas. Of course, they're a source of moisture and energy for things like nor'easters and tropical systems, and lake effect precipitation occurs near these. And I am going to discuss each of those in detail a little further ahead in my presentation. We also have mountains. The Appalachians partially shield coastal regions from air masses moving in from the interior U.S. So storm systems coming this direction, the mountains kind of block and deflect and moderate that air, and that moderates the air before it comes over the east side of the mountains. But they also block the western side, parts of West Virginia or western Pennsylvania, from some of these warm, humid air masses off the Atlantic Ocean. Also, they enhance precipitation on the windward side as they force air to rise up, cool, condense. We start to see clouds and precipitation. So on this side of the mountain, we start to see, some more increased precipitation. But then conversely, on the right side or the leeward side, we see less precipitation. Another situation that can happen east of the mountains, which is kind of interesting, is sometimes when we get an area of high pressure situated up in Canada, up in here. So the winds are coming from the northeast, and we start to get cold air that kind of funnels down the east side of the Appalachian Mountains, and what happens is it sort of gets dammed up there, and that's called cold air damming. And sometimes that can be a setup for some ice events or snow events on the east side of the mountain. So cold air damming also happens. It's a little more prevalent in the mid-Atlantic states, but it does happen along the eastern ridges of the rest of the region as well. And of course, higher elevations also tend to experience cooler temperatures, so they tend to see some more snow events or heavier snow instead of rain. Now, the mountains of West Virginia are one of the reasons why the state is one of the foggiest places in the U.S. So this map is showing an annual mean number of days with heavy fog. So the reds and the grays are showing areas that are generally foggier. So West Virginia being one of the foggiest places in the U.S., same thing with parts of New England. So like I said, the mountains of West Virginia are one of those reasons, because what happens is at night those hilltops cool off pretty fast. and then that cold, dense air sinks down into the valleys. So eventually, in the valleys, the air just keeps cooling, and it cools to the point where we start to get condensation and fog developing. And so also parts of New England also experience coastal fog, and that has a little bit more to do with some the cold ocean water in the Gulf of Maine and that area. So that is what this map is, and then this map down here is actually, or this graphic is showing right through here. You can see kind of these little white areas. That's actually showing some of the river valley fog across parts of southern New York and northern Pennsylvania. So then, like I said, agriculture, the region has forests and farmland. Vermont is the nation's #1 producer of syrup. Maine is the largest producer of wild blueberries. New York is the nation's second largest producer of apples, and Massachusetts is the second largest producer of cranberries. So ag is a very important part of the Northeast economy. And so across the Northeast, we have these 35 what we call major climate sites. And so if you look at the average length of the growing season at these different sites, it ranges from about 131 days in northern Maine, so about a third of the year in northern Maine, to 239 days at LaGuardia Airport. So, you know, 2/3 of the year for their growing season. And of course, like I said, huge influence on our ag. And you can see the moderating effects of the large bodies of water on surrounding areas on the hardiness zone map right here. So coastal areas, you can see the lighter green showing that they're in sort of the 6A or B hardiness zone. And actually, you can really see it along the Great Lakes, how there's just this narrow band that stays a little bit warmer, a little bit more moderated because of the influence of the Great Lakes. You can also see the higher elevations pretty well, so right here in West Virginia up into Pennsylvania, but especially across the Adirondacks and to the Green Mountains, and also up into northern Maine as well. Northern Maine also being, you know, in these areas a little further north, so we've got the higher latitudes, but the combination of those two make it a little bit of a shorter growing season in those areas. Now, the growing season has actually lengthened in the Northeast, and it is projected to continue to lengthen as well. The region is a major hub of transportation with numerous airports and highways, shipping routes, railways, ports, and that's what this graphic is showing, some of the major points of transportation across the Northeast. And so what happens is sometimes when we get these winter storms or tropical systems, even actually heat waves, nor'easters, ice storms, they can all negatively impact the transportation sector. And I'll talk about that in a couple of our nor'easter slides. But also weather events can negatively impact the energy sector too. So major hubs of transportation can be impacted by the weather. So across the Northeast, the prevailing flow of air is from the west. The jet stream, which is that river of fast-moving air upstairs in the atmosphere, the weather patterns and storm tracks that we see are closely tied to the position, the strength, the orientation of the jet stream. So for instance, what happens is during winter sometimes the polar jet can dive south, and this is this graphic right here on the top right. So here's an example. We've got the jet stream coming down this big old trough along the East Coast, and basically that just opens Arctic air. It's like a freeway for Arctic air to move right down into the Northeast. And we saw that actually in 2014 and 2015 in particular. So we can get these really cold Arctic air outbreaks. Now conversely, sometimes we can get a pattern where a ridge sets up, and so in this case the ridge is over on the west coast, but imagine if it was shifted to the east, we can kind of get this southerly flow of air that brings some warmer temperatures and more humidity our direction as well. So it really kind of depends on where the jet stream is, and so also the jet stream can be influenced by these patterns of variability in the atmospheric circulation. And we call them teleconnections, but basically, like I said, they're just patterns of variability in atmospheric circulation. You've probably heard a lot this year about El Nino, and that's an example of a teleconnection that can influence the jet stream position and influence the weather patterns across the U.S. and the globe. Another area that influences our weather, the Azores or Bermuda High, basically semi-permanent area of high pressure in the North Atlantic. So during winter it tends to be a little further east, but in summer the Bermuda High expands westward towards the southeast U.S. and basically it can usher in some hot and humid and tropical air, and especially in southern parts of our region. And it can also allow storm systems to tap into Gulf moisture and transport it north. It can also help guide tropical storms. So this is an example of the Bermuda High. So this is more of an easterly pattern, and this particular image is more attributed to tropical systems, but at least kind of gives you an idea. So kind of a weak one, you can see that the tropical system is kind of heading a little more north, but then this is more of that westward, strong, dominant Bermuda High, and in this particular case, that tropical system is heading towards the Gulf. But even without that tropical system there, you can see kind of the flow of air. So we've got this Gulf moisture, southerly, warmer, more humid air flowing into, in particular, southern parts of the Northeast. Next, we're going to talk about temperature in a little more detail. So temperatures across the region tend to be cooler in northern areas, warmer in southern areas. They also tend to decrease with higher elevation as you go inland. So the maps, the darker the blue, the cooler the temperature, the brighter the red, or the darker the red I should say, the warmer the temperature. So you can see northern latitudes a little bit more on the cool side, southern, southeastern latitudes more on the warm side. And so these are normal high temperatures annually for the Northeast. So our normal high temperatures annually range from less than 50 degrees in northern areas of Maine and Vermont, New Hampshire, down into southeastern Maryland and parts of Delaware where temperatures are more than 65 degrees. So normal low temperatures, which is this map, again cooler spots, you can see up in northern Maine, so higher latitudes, but then also on both maps you can kind of see this too. You see these little spots across West Virginia and southwestern Pennsylvania, so some of the higher altitudes right here. So like I said, normal annual min temperatures range from less than 29 degrees in parts of, oops, sorry about that. My mouse is apparently having just a few problems, so give me 1 second. There we go. So normal annual min temperatures range from less than 29 degrees right up here in those areas to more than 47 degrees down into parts of the southeast area of the Northeast. Temperature trends, this graph is showing the average temperature for the Northeast since 1895, and so that's the purple line. So basically this is average temperature for every year back through 1895, and you can see some cooler years back into the early 1900s, but then some warmer years as of late. And this line right here is the trend line. So what we're seeing is that the Northeast is warming by about 2 degrees or so per century. And of course, we are expecting that trend to continue into the future. The region does have 4 distinct seasons. January does tend to be our coolest month, and July tends to be our warmest. And normal July high temperatures, which is the left map right here, and they range from the mid-70s in parts of northern New England and the Adirondacks to the upper 80s. And again, these sort of same areas, you'll probably start to see these patterns, the warmer areas down here to the southeast in parts of Maryland and Delaware. Northeast summers can be warm and humid, in particular in southern parts of the region. Northern areas tend to be a little bit more moderated due to their latitude, and of course they do kind of get in on these cooler Canadian air masses that move through the region, so they're a little bit more moderated. Normal January low temperatures, which is this right map right here, shows temperatures ranging from below 0 in parts of northern New England into the upper 20s in parts of Maryland and Delaware. So some pretty cool temperatures. One of the things I asked on the survey when you guys signed up was, have we seen temperatures above 110 and have we seen temperatures below minus 50? And the answer is yes, we have. The Northeast has seen these major temperature extremes. So the highest temperature, 112, both in West Virginia in the 1930s. And then our lowest temperature, negative 52 degrees in upstate New York, February 9th, 1934, and February 18th, 1979. So this image is just showing an example of some heat damage along railroad tracks in Maryland, and they had shifted due to intense heat there. The Northeast usually does see heat waves annually. So a heat wave is defined as 3 or more consecutive days with a high of at least 90 degrees. Heat waves can be worse in urban areas, especially because it doesn't cool off at night in these areas. Also, a lot of the northern parts of our region don't use air conditioning. So it can also be, when they do happen in these areas, there are a lot of people who don't have the ability to cool themselves very well. And of course, they can cause negative health impacts and deaths. Now, along with heat waves, we do get increased energy usage. So, people are turning on their air conditioners or things like that, which can actually lead to blackouts because here in the Northeast, a lot of our infrastructure is aging or getting pretty old. So it adds a lot of stress when there's that increased use. So we get brown and blackouts when we do have these heat waves. And some notable heat waves were in July of 1993. So Philadelphia, Pennsylvania had 11 consecutive days with a high of at least 90, and there were more than 100 heat-related deaths in the city. In July 2011, there were a couple of heat waves during that month. One towards the end of the month produced 100-degree heat the whole way up into Maine. So that's this map on the right here. So areas that are shaded orange or dark red saw temperatures, at least a temperature or a high temperature of 100 or greater during July 2011. So all these areas, and then you can see even up into southern Maine, parts of even coastal Maine, down east Maine, saw some temperatures 100 or greater. And then areas shaded green or yellow, so pretty much a huge part of the rest of the Northeast, saw temperatures of at least 90 degrees. And actually, there were some sites that set all-time high temperature records that stand today. And an example of that was Newark. Newark, New Jersey set its all-time highest temperature of 108 degrees in July of 2011. And so the frequency, intensity, and duration of heat waves is expected to increase in the future. Now, conversely, the frequency, intensity, and duration of cold air outbreaks is actually expected to decrease. So cold air outbreaks can lead to, have numerous impacts, things like water main breaks and frozen pipes, and of course the health hazards of going outside when it's very cold. Ice can build up on waterways, and that can impact shipping and navigation. And if the outbreak actually happens in the spring after a period of warm weather, there can be major ag impacts such as damage to crops. And we actually saw that earlier this year where we had a brief warm-up in, well, not even a brief warm-up. March was a pretty warm month for us. And then all of a sudden we had this Arctic outbreak in April, and so there was some crop damage. So that does happen, across the Northeast. So one of the major cold air outbreaks, actually it was a couple, happened in February 2015. So just last year in February, the Northeast experienced a couple of them. And this top right map is showing the average temperature departure from normal, so for the month of February. So basically what you're seeing is these darker purples right through here or even through here are areas where temperatures for the month were about 9 to 15 degrees colder than normal. And then these brighter purples, or the magenta color, showing areas that were more than 15 degrees below normal for the month of February. So when it was all said and done, actually it was last February, the 2015, second coldest February on record for the region. And if you look at our 35 major climate sites, it was the coldest February on record for 15 sites. But then also, so February 2015 became the all-time coldest month on record. So basically, if you look at all months back through the period of record at these sites, 7 of those sites have our all-time coldest month in February 2015. So extremely cold month for our area. So of course, with the cold air in place, snow totals were generally above normal that month. So Boston, Massachusetts, they actually saw more snow in February than they normally see in an entire snow season. So it was their all-time snowiest month on record. And actually, it was estimated that the state lost about $1 billion. They lost about $1 billion in their economy just due to impacts from the snowstorm. And that particular month as well, the start of maple season was actually pushed back by about 3 weeks because it was so cold and snowy, it kept the sap from flowing, and then a lot of producers couldn't even get to their taps to get the sap as well. So really cold month. And then this picture down here on the right is actually showing some of the ice buildup in the Chesapeake and Delaware bays that same month. So this is the Chesapeake Bay right here, and this white area up in the upper part of the bay is ice buildup, and this is the Delaware Bay, and again the white area is showing where ice was building up. So that really impacted navigation and shipping in those areas. So the next thing we're going to discuss is precipitation, and normal precipitation ranges from about 30 inches to more than 55 inches. So what we see is that coastal areas tend to see more precipitation, so the greener areas, the brighter greens, showing where more precipitation annually generally falls, and then the yellows and oranges showing the lesser amounts. So generally, like I said, coastal areas see greater amounts, and then it decreases as you go inland. However, mountains, like I mentioned previously, can produce heavier local amounts. So you kind of see that in places like West Virginia, and then you can see it again up in the higher elevations of Vermont, and then right here, Mount Washington as well. And then this area right here we'll talk about in a bit, but basically that is east end of Lake Ontario, so they get to see a lot of lake effect snow. So their precipitation comes a lot in the form of snow. Conversely, areas that are blocked by mountains kind of see less, so you can see that a little bit right here east of the Appalachians, so in parts of the panhandle of West Virginia, Western Maryland, and then also south central Pennsylvania tend to see a little bit less. This graph is showing precipitation for the Northeast, so similar to the temperature one that I showed earlier, and it goes back to 1985, so annual precipitation each year back to then. And you can see each year is quite variable. So we have some pretty low years in the 1930s and 40s and the 1960s. I'll talk about this 1960s event coming up shortly. But then we see some pretty high years as well that were pretty wet. But overall, if you look at the trend since the 1890s, you can see that that trend is showing an increase in precipitation. And really, a lot of that is kind of stemming from the fact that we are seeing more extreme precipitation events in the Northeast. Before I get to that, I'll just mention that the greatest 24-hour precipitation total was 18.15 inches in Westfield, Mass. in August 19th, 1955. So 18 inches of rain in a 24-hour period. So the Northeast has seen this greater increase in extreme precipitation. Actually, compared to any other region, we've seen the greatest increase, and that's what this map on the right is showing. So here's the observed change in very heavy precipitation, and we've seen the greatest amount of it. And kind of with that, the Northeast has also seen an increase in flooding events, and this trend is expected to continue. A recent example of an extreme precipitation event, you guys may have seen this on the news quite a bit, was on June 23rd in parts of southern West Virginia. And so the greatest 24-hour rain totals from this storm, radar estimated we're showing about over 10 inches, but two of the sites that we have data for were showing 8 or more inches. So if we look at that, that makes it a 24-hour 1,000-year event. So basically what that boils down to is rainfall of this magnitude is only expected to occur or have a 0.1, so a 0.1% chance of occurring in a given year. So a pretty rare event. Excuse me. And it did become the all-time wettest day on record, the all-time wettest month on record for a few climate sites. So what happened was that runoff caused rapid rises on area waterways, and several of them had record or near record crests. Thousands of homes were damaged or destroyed, numerous roads were washed away, and it was likely the state's third deadliest flooding event with 23 fatalities. So this top picture is showing some of the damage to roadways, And then this picture is showing, of course, just some of the flooding. And then a little more recently, just last weekend, there was another 1,000-year event that happened in parts of Maryland. And that data table that I showed you with all that CoCoRaHS data, that was actually some of the data from this particular event. And so, like I said, another 1,000-year rain event that also caused very significant flooding in parts of areas of Maryland near Baltimore. So flooding can occur for many reasons. One of those, like I just showed, is flash flooding, especially during thunderstorms. We also can get a situation where heavy rain in cities with all of their concrete and asphalt, it just runs off, and so what happens is you can get some urban and street flooding as well. Another source of flooding is rainfall and storm surges from tropical systems, and I'm going to talk a little bit more about that in a few slides ahead. Storm surge from nor'easters can cause flooding along the coast. We also get situations sometimes where we get these slow-moving storm systems that don't really go anywhere, and they stall over the region, and we get periods of heavy rain from that. And of course, there's also flooding when we get heavy rain and snow melt, mainly in the spring, and then also in the spring generally when ice starts to break up and move on waterways, ice jams can cause flooding, and that's what this picture is here on the bottom. So right here you can kind of see that you can see the clear water, or the water that's free, and then right here there's this ice jam, and what happens is sometimes the water backs up and can flood areas behind it. So of course with flooding we do have major impacts, including loss of life and damage to buildings and roads and bridges, damage to utilities, substations, things like that, and ag damage as well. So of course, due to its proximity to the Atlantic, tropical systems and the remnants frequently do affect the Northeast U.S. And so this left map right here is showing hurricane strikes from 1900 to 2010. So this includes landfalling hurricanes and those that didn't actually make landfall but did produce hurricane force winds over land. So you can see that every coastal county in the Northeast has been impacted by a hurricane, with the greatest amounts along Long Island and Cape Cod, anywhere from about 7 to 9 during that time frame. So then over here on the right, what we're looking at is, on average, how often a hurricane is expected to pass within 50 nautical miles of a certain location. So basically, the frequency is pretty low in parts of Maine and New Hampshire, so you could expect a hurricane to pass by within 50 nautical miles every 30 to 50 years, but then it gets a little higher along Cape Cod and the Delmarva down here, anywhere from about 13 to 16 years. Tropical systems and their remnants have many impacts, strong winds leading to power outages and damage, storm surge, which is that rise in sea level associated with intense storms, can cause flooding and beach erosion. So this picture is before and after Hurricane Sandy. And you can see some of the flooded areas back here along the bridge. This is the before picture, here's the after, and then really just the immense erosion that happened. So nice beach, and then you can see the erosion after the fact. And of course, with higher sea levels, a storm that may not have caused flooding previously might in the future. Also, heavy rain can trigger flooding inland, and I'm going to show a slide on that in just a second. But models suggest that there's a slight decrease in the number of tropical systems in the future, but really an increase in hurricane intensity and rainfall in the future. So one historic hurricane was dubbed the Long Island Express, and it made landfall on September 21st, 1938 in Long Island, and then crossed Long Island and then made a second landfall in southern Connecticut. And it was a Cat 3, so it had max sustained winds of 121 miles per hour with gusts of 186 miles per hour, and it dumped about 17 inches of rain on parts of the region. So the water level, if you can imagine this, in New York Harbor rose 7 feet in just 30 minutes. And the Connecticut River in Hartford crested at about 19 feet above flood stage, and it was some of the worst flooding that the area has seen. So when it was all said and done, about 24,000 buildings, 6,000 boats were damaged and destroyed, 2 billion trees were destroyed, and there were more than 600 deaths and at least 1,700 injuries. So that was a major hurricane that moved through the Northeast. Now in August 2011, the region was already, it had already seen well above normal rainfall, so conditions were already quite wet. But then Hurricane Irene brought more excessive rainfall late in the month, and this caused flooding in parts of eastern Pennsylvania and New Jersey and southern New York. And then just over a week later, we had the remnants of Tropical Storm Lee come through, and that brought even more heavy rain and even more flooding. So the pictures on the left side are some of the damage. So this is in southern New York, and then this is in, I believe, Harrisburg or outside Harrisburg, Pennsylvania. And then this picture down here on the right is near Binghamton, New York, and this is showing some of the flooding there. And it was the highest water level for the Susquehanna on record. This event caused that, and it's actually still the highest water level on record, so that record still stands. But just amazing, intense flooding from these systems coming through. And that's inland, so just kind of to point out that we can get flooding coastally, but these systems can also dump a lot of rain and trigger flooding inland as well. Now, of course, Sandy walloped the Northeast in late 2012. It is the second costliest U.S. weather disaster, only behind Hurricane Katrina. And more than 20 sites along the New Jersey and New York coastline saw record high water levels and flooding. And after Sandy, flood maps actually were updated for the first time in 20 years. So it was impetus for flood maps to be updated because some areas that they didn't think would flood did. So more than 375,000 buildings were damaged and destroyed in just New Jersey and New York, and there were over 150 deaths. About a foot of rain, some areas saw a little bit more, fell in parts of Maryland, and it made it the wettest October day there. And then further inland, actually nearly 2 feet of snow fell in parts of West Virginia. And Beckley, West Virginia set a new record for greatest October snowfall. And then even further inland, in Lake Erie, actually waves up to 20 feet caused flooding there. And so 8 million people lost power from Sandy, and 65% of New Jersey was without power. And then there were fuel shortages due to damage and power outages and long lines, and that led to rationing for up to 2 weeks in New Jersey and New York City. So Sandy, a very impressive event for the Northeast. Now, kind of the opposite of precipitation, droughts, we do experience droughts in the Northeast. They do generally tend to last 1 to 3 months, and they occur every 2 to 3 years. And the drought category is based on a couple of things such as precipitation, stream flow, soil moisture, drought impacts, and observations by observers. And they tend to, like I said, be seasonal in nature, actually lasting less than 6 months, I should say. Droughts can have numerous impacts, and 3 major ones are on ag, water resources, and fire. So chances of seasonal droughts are expected to increase in the future. And the bottom right picture is of a drought in Maryland from 2002. You can see some of those low water levels. And then up here on the left is a picture of some stressed corn in northern New York from this past July, because parts of the region are currently in a drought. The new drought monitor came out this morning, and I apologize, I forgot to update this one because this one is from the 12th. But this is current, this is as of this morning, and 27% of the Northeast is in a drought. And on this map, areas of tan and orange are showing where drought conditions are located, and like I said, that has expanded a little bit, especially up in New England and even in parts of western New York that has also expanded. So some of the impacts from the current drought include near to record low stream flow, and so this picture I took, this is near my house, and you can see one of the little streams, and pretty low stream flow running through that. And groundwater reservoir levels are also running low, and there have been some reports of wells going dry. So many towns, more than 130 in Massachusetts, more than 50 in New Hampshire, some other towns throughout the region have implemented water bans and restrictions. And just a note though, New York City droughts are actually, their water droughts are more based on the Catskills because that's where the reservoirs are located. So while you can see that, kind of New York City is in this, this moderate drought area, it's more based on what's going on in the Catskills for them because that's where they get their water from. There have been some ag impacts, like I just showed you on the previous screen. Some crops and pastures have been slow to grow, and they've been pretty stressed. Some farmers are reporting crop losses and low yields as well for corn and possibly soybeans and hay. And so many farmers here have been relying on irrigation, and so that's, some of them don't have the capacity to have the irrigation, so that's been driving up prices for farmers as well. And then also, like I mentioned, fire danger and activity. So normally what happens is once plants start to grow leaves in the spring, say like June, the fire risk goes down. But this year we've been so dry, we've had an above normal number of days with moderate or high fire danger rating. And then the number of fires has also been above normal. And then there was a report last week that Massachusetts actually has had an unusually high number of lightning strike fires, which is unusual for them. So the benchmark drought that occurred in the Northeast was in the 1960s, and you may remember that I showed you, the annual precipitation, and I said, okay, here's the 1960s. Well, there was a big drought in the 1960s, and that's kind of like the benchmark for the Northeast. And that drought did last from the fall of 1961 through 1967, and it affected the whole Northeast, and for 3 years, almost half the region was in either extreme or severe drought. So this is from October 1963. Some sites did not receive measurable precipitation at all during October 1963. Actually, it's still the driest month on record for 9 of our major sites. And so, like I said, that's this is showing precipitation totals for that month, and you can see a lot of these zeros and a lot of traces down in the Washington, D.C. area, even the Baltimore area. This is Delaware, some traces down here. This is New Jersey, and this is southern or southeastern Pennsylvania. So a very, very dry time for the Northeast. And reservoirs and groundwater supplies and waterways were reaching record or near record lows for that time. And a lot of communities implemented water restrictions, emergency water restrictions. Some even had to have water hauled into their area. And like I mentioned, the New York City reservoir system actually was at 31% of capacity back in the 60s. So ag was also impacted with crop and milk production losses, and more than 1,000 fires broke out in the region. And because of the extreme fire hazard in New York, they were forced to close their parks and cancel the big game hunting season. Snowfall is what we're going to move on to, and normal annual snowfall ranges from less than 20 inches to more than 140 inches. And lake effect areas east of Lake Ontario generally see the largest amounts right here. That's that blue circle. And this is Mount Washington, which we'll talk about in a second. So northern areas and higher elevations do tend to see greater amounts of snowfall than southern areas. So the blue showing the greater amounts of snowfall. Northern areas, higher elevations right here compared to southeastern and parts of our region, which tend to see a little less. January is usually the snowiest month. The Northeast has seen less winter precipitation falling as snow and more falling as rain. In addition, the region has also seen snow melting earlier in the spring and decreased snow cover, and that is expected to continue. So the Northeast does have its fair share of snowfall extremes. Mount Washington is the Northeast's tallest mountain, and this is Mount Washington in the picture. And if you look really close right up here, you can see the observatory on top of the mountain. The region's greatest 24-hour snowfall was 49.3 inches on top of Mount Washington back in 1969. And it's also home to the highest wind speed in the U.S., so in the entire U.S., which is 231 miles per hour. So not snow-related, but I still thought it was pretty neat and wanted to sneak that in there. Pinkham Notch, New Hampshire, which is nearby, holds the record for the Northeast's greatest snow depth, which is 164 inches, which also happened around the same time as the greatest 24-hour snowfall. So nor'easters are low-pressure systems that get their name from their strong northeasterly winds, which can be hurricane force, which is 74 miles per hour. They can be very strong wind producers. They also produce heavy snow, heavy rain, high winds, and blizzard conditions. And so these storms get their energy from the strong temperature difference of interior North America and then the western Atlantic, the Gulf Stream. So the Atlantic provides also a source of moisture for them, and they can cause loss of life and flooding, erosion, power outages, disruption to transportation, and economic losses for the Northeast. And one of the most extreme nor'easters that we saw was back in March of 1999, and it was dubbed the storm of the century. Snow fell from Maine the whole way down to Florida, and snow totals were more than 40 inches in some areas, and low temperatures dropped to -12 degrees. Every major East Coast airport was closed. So this is what I was saying previously about transportation being affected. So every major East Coast airport closed. There were 300 deaths, and the storm did $9 billion in damage. And so the National Centers for Environmental Information ranked snowstorms for the Northeast based on their impacts, and this one ranked as the second highest in terms of impacts for the Northeast. Another nor'easter that happened a little more recently was back in January of this year. It was a pretty impressive nor'easter from January 22nd to the 24th, and snow totals were up to 42 inches, and the map at the top is showing the snow totals for that storm. So pretty much any area that's shaded in a blue color had more than a foot of snow, but really these darker blues through here are showing where more than 30 inches fell. So 5 of our major sites, including Dulles Airport and Central Park, saw more snow in a single day, just one day snowfall, than they do in an entire snow season. So really impressive storm. Wind gusts were to 75 miles per hour, and that caused blizzard conditions for up to 9 hours and contributed to record and near record water levels along the New Jersey and Delaware coasts, and this resulted in flooding and also moderate to major beach erosion. So this is an example of some of the erosion from that storm along the New Jersey coastline. Transportation was greatly impacted as well, so all flights into and out of Philadelphia and the 3 Baltimore Washington airports were canceled on the 23rd. And nationally, during this storm, 11,000 flights were canceled, so sometimes it trickles down. So these airports close, and then that causes other delays and cancellations other places. Traveling by car was also pretty difficult because roads were impassable, travel bans were enacted, hundreds of thousands of people lost power, and schools were closed for up to a week. And so the ranking for this storm was the 6th most impactful snowstorm for the Northeast. Areas east and south of Lakes Erie and Ontario are prone to lake effect snow events. So what happens with lake effect is cold air passes over these large warmer bodies of water, it picks up moisture and heat, and then it starts to rise. So as it starts to rise, it starts to cool and condense, and eventually it starts to form clouds and snow. And so the topography of the land also kind of helps create the snow as well, because it's forced, the air is forced to rise, and so it dumps out the snow in places like Buffalo. And sometimes you can get thunder and lightning, but really lake effect can also happen on smaller bodies of water. I've seen small little lake effect events that happen in the southern ends of some of the Finger Lakes, and I've also seen it set up a few times off the Chesapeake Bay. So those are pretty infrequent, but kind of this sort of similar situation where you have the cold air moving over the warm waters, and you know, get the lake effect. The lake effect area east of Lake Ontario is one of our snowiest spots in the Northeast. So they average 10 to 13 feet of snow a year. And with lake effect, there can be snow in one spot, but it can be sunny just a mile away. It's really impressive. But the lake effect impacts, while they can be very significant, they can also be very localized. So there was a major lake effect event south and east of Buffalo in November of 2014, and you may have heard about this one on the news as well. It dropped more than 5 feet of snow on some areas, and at times it was falling at about 6 inches an hour. So the picture up here on the top is showing the area in red, the area that got the most snow, over 70 inches. And then all these areas through here were also affected, but this was kind of the core of what was going on. And then this picture over here on the right is of the New York Thruway, or a major highway that runs through and across all of New York, but this was taken right near Buffalo during that event. So thousands of motorists were stranded during the event, and then because of the weight of the snow, there were hundreds of major roof collapses as well. And this is considered to be one of Buffalo's most significant lake effect events, which is pretty impressive considering how snowy the Buffalo area can be, but this was also a very impressive storm. The Northeast is also prone to snowstorms, or I'm sorry, ice storms. Some impacts include downed trees and power lines and impossible travel, and a major ice storm occurred in early January 1998 in northern New York and northern New England, and they saw 2 to 3 inches of ice accumulation. So power outages lasted for up to 25 days, and 80% of Maine's population lost power, and forests really took the brunt because they were just devastated. And you can see this these pictures from Vermont where just the branches are just broken and decimated. So they can be pretty damaging as well. The last topic for today is going to be severe weather, and so thunderstorms and lightning are pretty common here in the summer, and June and July are our peak months for severe weather. Straight line winds or downbursts can cause a lot of the wind damage the Northeast sees during severe thunderstorms, and basically downbursts are just areas of rapidly descending air beneath a thunderstorm. The air hits the ground, it spreads out, usually in a fan pattern or a straight line, hence the name straight line winds. And you may have heard them called microbursts, but basically that has to do with the size of the downburst. So microbursts are small downbursts. And a lot of times what happens is people think, oh, a tornado went through, look at that damage, but really it's a downburst because the wind speeds and damage can be pretty similar to tornadoes. So that's what this image is of, and actually National Weather Service, they're the folks that go out and determine if it was a microburst or if it was a tornado. But one of the ways that they determine that is the way that the damage is oriented. So basically over here on the left side, you can kind of see some of these arrows, and it's all sort of in a straight line or slightly fan-like. So, you know, it's oriented this direction and maybe curving out a little bit, but really it's all sort of one way. But then if this one on the right sort of shows that swirl pattern, which is more characteristic of a tornado. So the way to kind of remember it is that downburst winds can blow out while tornado winds converge in. NOAA's storm database shows that the highest wind speed associated with a downburst in the Northeast was 150 miles per hour. So these events can be pretty impressive. So if you get a group of downbursts together, they can produce a widespread, long-lived windstorm called a derecho. And basically, there has to be certain characteristics. And this happens when they have to have winds greater than 58 miles per hour throughout most of the storm. It has to produce damage along a path of at least 240 miles. So these storms are most common in late spring and summer, and the Northeast usually sees one every few years or so, and that's what the map on the top right is. So this is showing areas that see them more often compared to areas that don't, but you can see there are parts of the Northeast that do see them every 1 to 2 years to 4 years or so. A major one that occurred back in June 29 and 30th of 2012, and that's the bottom left picture right here, and this is showing hourly radar how the storm advanced. And the numbers on here are wind gusts along the path. And so this one happened to move 700 miles in 12 hours with an average speed of about 60 miles per hour. And the bottom graphic right here is showing the areas that were impacted. So basically any area in gray was impacted by this event. The blue dots representing wind damage reports, the yellow dots showing wind gusts of more than 74 miles per hour. Green dots show hail, and then the red dot, I think there might be only one, shows a tornado. But in the Baltimore, Washington area, more than 2 million people lost power, and some were left without power for a week. And then one of the major impacts, too, was towers and lines for land and cell phones and the internet were also down and disrupted. So this was a pretty big event across the Northeast as well. Severe weather, including tornadoes and hail, the average annual number of tornadoes ranges from 0 in Rhode Island to 15 in Pennsylvania. They tend to see the most, and that's what this image is showing, the average annual number of tornadoes. And all the Northeast states have reported tornadoes, but generally most are weak. They're generally EF0 or EF1. May and July, or May, June, and July, they're the peak times for tornadoes, and the peak time of day is late afternoon and early evening. There's only been one EF5 tornado reported in the Northeast, at least since 1950, and that occurred in western Pennsylvania on May 31st, 1985, so only one EF5. Tornado outbreaks are pretty unusual here, but they can happen. In 1998, we saw one, back-to-back ones actually, so over the course of 3 days, Pennsylvania had 41 tornadoes. And as far as hail, we do get some hail. It tends to be smaller, but from the NOAA storm database, we've had reports of hail up to 4.5 inches in diameter. And that is all I have for today, but if you do have any questions, you can feel free to contact me. I have my direct email, which is sgh58@cornell.edu, and then the Northeast Regional Climate Center, which gets checked regularly as well, nrcc@cornell.edu. You can have my telephone number, or you can also check out our website. We have a lot of amazing information and data on our site, and that's www.nrcc.cornell.edu.
Samantha, thank you very much. Excellent presentation. Wow, a lot of good stuff there. I got a quick question for you. We've got questions coming in, but as far as tornadoes, I always remember, having lived in New England, there seems to be a sweet spot, what you would call it, southern Vermont, western Massachusetts, northwestern Connecticut. Can you tell me why that region seems to have more tornadoes?
Yeah, that's a good question. I don't know if I have a direct answer for you on why they see more. I'm sorry. I can look into it.
It was always interesting that especially back in the 70s, I remember them getting a bunch there. But hey, we've got some questions coming in, so let's jump to those. And folks, this presentation is being recorded, so that'll be on the web, and also Samantha's slides will be on the web, so you can go by slide and take a look at anything you might have missed during the presentation. Jerry wants to know the Worcester 1953 tornado that came through and did a lot of damage in that. Do you know what that was on the EF scale? A very famous tornado there.
Oh, I don't know. I can look that up for you, but I don't know off the top of my head. I'm sorry.
Okay, it's funny. We've got a couple CoCoRaHS observers out here in Colorado that lived in Worcester, and I remember one of them telling me that they watched that go through. So.
But it was 1950s,
1953, yeah, May of, or I think it was June of 53. But,
okay, I'll make a note on that.
Okay, sure. So here's some questions coming in. Let's take a look at those. And James wants to know that are any statistics being kept on extreme daily temperature swings? So he's down in Texas, in Austin, Texas. He's had 60-degree swings and in a day, and 30-degree swings in an hour, and I wanted to know how the Northeast compares to that.
That's interesting. I don't know of like a database that's keeping data on temperature swings. You know, of course, we have daily high temperatures, daily low temperatures, those sort of things, and I know that frequency of high temperatures that are being set is double compared to low temperatures. So more frequently we're setting these record high temperatures versus low temperatures, but temperature swings, or that temperature difference, I don't know off the top of my head a place that is keeping those stats.
Okay, great. Well, let's go on to the next question here. And Gail writes in, and Gail said that she noticed that you said there's a trend in increased precipitation, but also seasonal droughts. Could you explain that a little more? She said it, and she's also from Austin. She said that seems a little counterintuitive.
It does, yeah, absolutely. So, so with warming air, a warmer air mass has the ability to contain more moisture. So basically what happens is it has a greater ability to evaporate moisture into it. So we can go longer periods of time without getting precipitation, but then once it does start to precipitate, there's more moisture available to the atmosphere to produce these bigger rain events. So longer stretches between rain, but then more moisture and heavier rain when it does rain.
Okay, and we got actually I just got an email quickly here from John Quinlan, who's our CoCoRaHS coordinator and works at the Weather Service in the Albany area, and he's got the answer to the Worcester tornado. June 9th, 1953 was an EF4, he says. So there you go. Nice to have all kinds of folks and some of our meteorological and climatological friends on the presentation. Well, let's see what else we got here. We've got some other questions coming in. Paul wants to know that there hasn't been a major hurricane to hit the U.S. mainland since 2012. He wants to know, is that due to the absence of the Bermuda High?
So a little bit from what I've been reading, so there are these variations. There are high activity eras of hurricane activity in the Atlantic, and then there are low eras as well. And so it looks as though we've been in a low era. For more information, I can point you to the National Hurricane Center because they're the ones that really study, this information. But the Bermuda High does influence like the track of these storms as they form and as they get closer to the mainland. I know the past few years there have also been just non-conducive conditions. So last year we had El Nino conditions, which basically increases shear, or shear is basically wind speed changing in direction with height in the atmosphere. And so for storm development, hurricane development, they really need an atmosphere that is more steady, or with less shear, I should say. And so what happens in like an El Nino year is that shear kind of deters them, sort of tears them apart isn't technically how I would explain it, but it kind of gives you an idea. So it's harder for them to form. It sort of does tear them apart. So so last year I know that was part of the problem, and I think we're just in this lower frequency of hurricane period as well.
Great, and we got a thank you from the top of Mount Washington. Tom writes in. He's a PSU grad, Penn State grad, and he just wanted to thank you for the presentation. So I thought I'd put that in there. Susan, as long as we're talking about tornadoes, asks that she didn't remember many tornadoes in central Maryland in the 60s and 70s, but there seem to be more now. Has the incident of tornadoes increased in that particular area? And you may not know this off the top of your head. But.
Yeah, I know. I'm like getting all these tornado questions. I don't off the top of my head. Yeah, and tornadoes are one of those things that we know quite a bit about, but we also are still constantly trying to study them. And then also, we're not quite sure how climate change will influence those as well. So I would say, A, it's an area of study, and I don't really know if there has been an increase, or, the storm database from the National Oceanic and Atmospheric Administration, where I pulled some of the data from, goes back to the 1950s. And so part of the thing that we have to think about too is we do have different conditions that we do. We have different conditions now than we did back in the 60s. We're definitely a warmer atmosphere, but then also the prevalence that storms are getting reported as well has increased. So I guess that would be my answer for now.
Okay, and actually John Quinlan's got an answer to my question earlier about the tornadoes in western Massachusetts. He says there's a secondary max in tornadoes across eastern New York and western New England due to interactions between the mountains and the river valleys. Storms typically descend from the Catskills, and spin-up occurs in the Hudson Valley due to something we call vorticity stretching, or the spin of the parcel of air. So there we go. And again, great to have extra eyes and ears out there to help with these questions. Here's another one coming in, and if you have any questions, go ahead and type them in now, and we'll be glad to, or Samantha will be glad to answer them. This is a Pennsylvania question, and Frank writes, he wants to know, how can Department of Environmental Resources regulate the whole state water drought system with two different watersheds, the Ohio Valley and the Chesapeake? So he's wondering, the question is, can they regulate two different watersheds with that?
I'm not sure exactly what you mean by that. So, like, I guess, yeah. So there are two. I mean, so there's the Ohio River Valley, and then the Mid-Atlantic sort of area as well. But I guess what does he mean by regulate?
Yeah, I'm not sure here. Regulate the whole state water drought system with two different watersheds. Frank, if you want to write in again on that, and kind of that'll be fine. We'll take any more questions here, and waiting for a few more to come in. Really great stuff. It was interesting to see the fog, how that, I remember living in Maine and New Hampshire at one point, and just amazing how many foggy days we'd have there, and then also down in the Appalachians. So certainly did get those. We'll take Frank's question offline. I'll have him, Frank, if you could go ahead and send that in, that would be great. We're gonna call it a day here. I think you've done a great job. Thank you so much for being with us, and appreciate you coming on board today to talk about the climate of the Northeast. Great pictures, great graphics, and we really appreciate your explaining that.
Thanks, Henry.
Well, folks, we're going to say so long to Samantha, but mark your calendars and please join us for our next webinar, and that one's going to be on Thursday, September 29th, so quite a ways in advance, but you got plenty of time to sign up. We will air the episode, the final episode of our climate series, and we'll look at the weather and climate of the southern U.S. This webinar will feature Barry Keim, Luigi Romolo, and Alan Black. They're all with the Southern Regional Climate Center in Baton Rouge, Louisiana. So don't forget to sign up for that. We'll have that on our website here shortly, and we'll have that for you guys to don't forget to sign up there. And finally, our last thing when signing off today, please take the survey. That'll pop up on your screen. You'll see that shortly. Well, until late September, this is Henry Regis for the rest of the CoCoRaHS headquarters team saying so long for now and have a great afternoon. Thanks for being with us.